At the local market I found this Bluetooth speaker in parts, but since it was cheap I bought it and took it home. I would love to save it from trash, and I think it has potential for small do-it-yourself project. You can see how it looks originally in a picture. In short, it is 10-watt speaker with LED light that changes rhythm depending on the song and has 1200 mAh battery. So I tried all the plastic pipes that I had approximately that size to return it to an original look. So they were either too small or too big. Since I have a lot of different speakers in the attic, I found one that could be a good base for this project. So let's start. Why it was disassembled and thrown away? Well, the speaker has a micro USB charging connector and it was smashed and it fell off. It could not be charged anymore. So that is the reason. I looked online pinout for micro USB connector and soldered two wires for plus and minus, and it tested fine. I'll show it to you a little bit later. I disassembled the speaker to see if the hole matched the size of the new one. I removed the old one and it should be fine. Here you can see one RGB LED diode which reflects from the white speaker cone. And you can also see the difference between the old speaker and the new one. Before I try to mount anything in it, it is necessary to clean the speaker. When the metal mesh from the front is removed, I come across a thin sponge that falls apart and it is full of dust. Luckily it is easy to remove it in combination with metal scraper. After that comes washing it with soapy water. It is important to dry everything well after wash, because I also think of gluing some parts. There is some damage from the front, I'll have to address it later. In order to completely disassemble it, I had to hit the hot glue with a heat gun to pull some wires, and there is a couple of screws holding whiteboard with LEDs. After that, finally you can see all the parts of this Bluetooth speaker, and these are the main control panel with the screen, the battery, the LED PCB board, and the speaker with its LED diode. I forgot to show you the thin black wire which is actually a radio antenna. Now I can clearly connect everything and show you that it's alive! I'll keep the back of the original speaker because there are buttons and it will be easy to install it, and it will also give extra protection in case of fall. There is no damage to the main board, screen, and so on. Once I have roughly cut the template, it's time to mark the hole on the back and cut it with Dremel. Of course, I could also drill small holes like I did in some places. After that, it is easy to push the cut plastic. I did dry fit everything and it fits perfect. I have a small hole in the front of the speaker, but as I have LED lights on the inside, it's time to design the front opening. I decided to cut it in the shape of the Greek letter Sigma. Or if you rotate the speaker, it is the letter M as music, etc. The holes were drilled and cut with the same cutting Dremel disc. I refined the cuts in more details with the small metal file. As I cut everything from the front, it is time for the final cleaning and sanding on the front. I was thinking of painting it but gave up because in the end it didn't turn out badly with just wet sanding, and I don't have paint for the plastic at the moment. So nice. To protect the speaker insides, I will put a thin plastic that I took from under the faulty PC power supply. It is easy to cut and has excellent dimensions for this project. I wanted to sand the plastic, but I gave up because I wanted the light to pass through the opening as much as possible, because there will also be a metal grill in front. After a few more small cuts, the plastic fits perfectly inside beneath the speaker. Now it's time to start gluing a couple of things, so I started with the LED located in front of the speaker. For this I use MS polymer glue, which is used a lot in the industry, as for example in electronics. You often see that the components are glued with white mass. Well, that is MS polymer. I applied little glue first, so I thought it was too little, so I added more. When I clamped everything, it moved, so I added more just in case. It can be never too much, right? Next up is the battery. The original 1200 mAh battery was too weak for me, so I put 3 pieces that were taken from broken laptop. To make sure that the batteries are okay, I first discharged them and then charged and tested their capacity. Parallel connected like this, they turn out to be around 5000 mAh. So now battery's capacity is 4 times more than it was. Not too shabby. Whenever I disassemble the laptop batteries, I leave the nickel plate as much as possible to easily solder it with a wire. To make sure the wire connections are tight as possible, I put shrink tubes, zip tie them together and wrap them with insulating tape. The next thing I glue is the transparent plastic. In order to apply the glue as precisely as possible, I first mark it roughly with a marker pen where the edges of the foil are. I overdid it a bit with the glue on one side, but while it was still wet, it was easy to clean it off because the surface is smooth. The next thing I glue is the speaker itself, but in order to be as tight as possible, I drill a couple of holes so that I can screw it in also. I turn the speaker wire to the right so that it does not interfere with the light that will be under it. It is slowly starting to look like a speaker. I like the idea of mechanically connecting the back of the speaker, so I did it with long screws, which I will paint later in black. While drilling it, I also drill a hole for a DC connector, through which the battery will be charged. Before painting the front metal mesh protection, I have to flatten it a bit and scrape the parts that are very rusty. There are a couple of holes in it, but it's fine. I use black spray paint and paint it in light coats 3 times, and I'm thrilled with how it turned out. It comes back relatively easy, and in the end it is only important to bend the ends from the other side. I'm also slowly installing the control panel mainboard, which has its original slots and screws that hold it in place. The screen, button and other connection fits perfectly, so that is also reason I kept the back of the original speaker. I cut a slot for a white PCB board that contains LEDs. Glue it and a new battery with MS polymer. I'm also fixing the cracked screw slot you saw at the beginning of the video. After I soldered the DC connector and put the shrink tube in, I put in the long screw that holds back plastic. I tried soldering other wires for radio antenna to see if there would be a better signal, but original wire somehow worked the best, so I glue it. Everything is connected and it's time to put on the screws and assemble the speaker. So I put rubber feet that are recycled from a skate that has casters for wheels. Since there will be a lot of outside, backyard and garden use, I wanted to make it stronger somehow. The rubber is perfect dimensions and it will reduce vibrations while the speaker is playing or if it falls. MS polymer is used for glue. I'm careful not to apply glue across the joints, because if I cut the rubber along the joint line, I can easily open the speaker if needed. I put a heavy screw storage box to press the rubber while it was drying, but one of my legs moved. I realized that after a few minutes, so I immediately peeled it off before it dried. I let the polymer dry to show you how easy it is to remove it and how rubbery it is. It's time to show you how it works. Final thoughts. When I use silicone in a tube, or in this case the glue, I often wrap the tape or nylon around all the plug parts so that the glue does not dry out. Of course, I use the silicone gun, which is cheaper, and the glue leaked from the back, dried up, and when I use it again, it broke. So don't use cheap glue gun or you'll waste glue like me. But if that happens to you, you can always go old school and use hammer. That's it for this video. I use it for 6 months now and it's a great speaker with great lasting battery. Thank you for watching.